Before beginning, I would like to offer my warm greetings to everyone watching. Today, as Sumiran Rathod of Class 90, would like to present a PowerPoint presentation on the Pythagoras Theorem, a very fascinating topic which is very inappropriately considered as simple and straightforward with nothing out of the ordinary. So let's make it interesting. Pythagoras, born 570 BCE, Samos, Greece, was a Greek philosopher, mathematician, and founder of the Pythagorean Brotherhood. Many mathematical and scientific discoveries were attributed to Pythagoras, including his famous Pythagoras Theorem, as well as the discoveries in the fields of music, astronomy, and medicine. Pythagoras theorem, the well-known geometric theorem often attributed to Pythagoras, states that the sum of the squares on the legs of a right triangle is equal to the squares on the hypotenuse, or in familiar algebraic notation, a square plus b square equals to c square. Proving a theorem through rearrangement method. Take any right-angled triangle with legs A and B and hypotenuse C. Use 4 of them to make a square with sides A plus B as shown. This forms a square in the center with length C and thus an area of C square. However, if we rearrange the 4 triangles as follow, we can see 2 squares inside the larger square. One that is A square in area and one that is B square in area. Since the larger square has the same area in both cases, that is a plus b whole square, and since the 4 triangles are also the same in both cases, we must conclude that the two squares, a square and b square, are in fact equal in area to the larger square, c square. Thus, a square plus b square equals to c square. The converse of the Pythagorean theorem is that if the squares of the length of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. That is, in triangle ABC, if c square equals to a square plus b square, then angle B is a right angle, triangle ABC being the right triangle. The converse of the theorem can be verified using this given proof. Now let's see some real-life uses of Pythagorean theorem. Square angles in buildings. To make sure that the buildings are in square shape, Pythagorean theorem is used. A set of Pythagorean triplets are used to construct squares corners in between two walls. Surveying in topographical sheets. This theorem finds huge application in the field of geography for the construction of various topographical sheets. Architecture and construction. This theorem finds application in various architectural fields, mechanical labs, during the construction of roofs, etc. Painting on a wall. Painters use ladders to paint on huge buildings and often use the help of Pythagoras theorem to complete their work. Navigation. In the case of two-dimensional navigation, Pythagoras theorem can be used to calculate the shortest distance between 2 points. Facts about the theorem. Although Pythagoras first proved the Pythagorean theorem, the idea is linked to early Babylonians. History is that Pythagoras studied with men known as rope stretchers, who were men that built pyramids. The Pythagorean theorem was discovered through the ropes that were used to calculate lengths needed to build pyramids in order to lay their foundations accurately. Originally, Pythagoras thought that the Pythagorean theorem was based solely on triples, but later, through the discovery of irrational numbers, found that it just had to satisfy the equation a square plus b square equals to c square. There are many proofs of the Pythagorean theorem. One came from the contemporary Chinese civilization found in the oldest extant Chinese texts containing formal mathematical theories, the arithmetic classical of the gnomon and the circular paths of heaven. The proof of the Pythagorean theorem that was inspired by a figure in this book was included in the book Vijayanagata Root Calculations by the Hindu mathematician Bhaskar. Bhaskar's only explanation of this proof was simply behold. So, this was all from my side. Thank you for watching.